This type of question, we've got resistors in series and in parallel. So to work out the combined and total resistance, we have to split it into sections and then put it together. So the total resistance will be these R1 and R2 and R7 added up in series, plus this section of the question added in with that series. But first we have to find out the parallel resistance. So if you take just this part of the question, then the resistance in parallel, 1 over, will be equal to 1 over R3 plus R4, because they're in series, plus 1 over R5 and R6, because they're in series. Don't forget, if it's in series, you just add them together. So if we put the numbers in for that, you get 1 over 2 plus 2 plus 1 over 4 plus 2, which is equal to 1 over 4 plus 1 over 6. Well, that is equal to 1 over Rp, the resistance in parallel. If you work that out and invert it, Rp becomes 2.4 ohms. So now we've got enough information to work out the total resistance of this circuit. So the total resistance is equal to R1 plus R2 plus the resistance in parallel, 2.4, plus R7. So that becomes 2 plus 3 plus 2.4 plus 4. If you add all that up, 3, 4, 5, 6, 7, 8, 9, 10, 11.4 ohms. That's the total resistance of the circuit. Now we can then progress this question and work out the total current supplied. And this goes back to Ohm's law, I equals V over R. So in this question it's a 24 volt supply and the total resistance is 11.4. Therefore the current supplied is 24 divided by 11.4, which comes out at 2.1 amps. So from that we can now then work out the voltage drop across the series part of the circuit and across the parallel part of the circuit. So voltage drop across series, V equals I times R, but in this case the resistance in series is added up to 2 plus 3 plus 4, or R1 plus R2 plus R7, which is equal to 2.1 amps multiplied by 2 plus 3 plus 4 which is equal to 18.9 volts. So, process of elimination, we can now find the voltage drop across a parallel part, because we know that the total voltage is 24, and we can deduct the voltage drop across the series part of the circuit. So voltage drop across parallel PS and VP is equal to 24 volts minus 18.9 volts, which is equal to 5.1 volts. So with that in mind, we can now find the current in each branch of the parallel part of the circuit. So current in branch R3 plus R4, this part, I equals V over R, Ohm's law, where it's a V parallel, which was 5.1 divided by the total resistance, which, because it's in series, this part of this parallel circuit, you add the two together, so 2 plus 2 is 4, and that becomes 1.275 amps. Now we can find the current in branch R5 and with R6, this branch of the circuit. Again, back to Ohm's law, is equal to the voltage in the parallel section divided by the total resistance in this part, which will simply be 4 plus 2. So you end up with 5.1 divided by 4 plus 2, which is 456, which is equal to 0.85 amps. So if you put that on the circuit, I is equal to 1.275 amps, and this part I is equal to 0.85 amps. So with all the information we've worked out so far, we can now find the voltage drop across each resistor. Again, going back to Ohm's law, but using the values relevant for each part. So if we start with R1, the voltage drop is equal to I, the current, multiplied by the resistance, R1. Now, earlier on in this question, we worked out the current in this part of the circuit. I was equal to 2.1 amps. So that is 2.1 multiplied by 2 ohms is equal to 4.2 volts. And if we go for the same for R2, V equals I times R2, which is equal to 2.1 multiplied by 3, which is equal to 6.3 volts. Then R3, V equals I times R3. In this case, the current we use is this one here. That's 1.275 multiplied by 2 equal to 2.55 volts. R4, V equals I times R4, 4 equals 1.275 from this figure, multiplied by 2 again 2.55 volts. Moving on to R5. R5. In this case of current, the value I we use is 0.85. 0.85 multiplied by 4, which is equal to 3.4 volts. R6, V equals I times R6 equal to, again, the current's 0.85 and the resistance is 2 ohms, and that becomes 1.7 volts. Finally, R7, V equals I times R7. The value for I we're using this is the 2.1 amps. 2.1 multiplied by R7, which is 4 ohms, which becomes 8.4 volts. And there you have it. Quite a complicated question with lots of different parts, but again, you're only using Ohm's law, and you just have to remember how to add up resistors in series and resistors in parallel.